Here we go. Standard deviation. The letter for standard deviation is sigma. Believe it or not, you were calculating, you were seeing that already over and over again as you were using one variable stats. So I will show you that it's right here. Look at where my pencil is. That is the sigma. So that's your standard deviation. Think about deviating. When somebody's deviating from the truth or deviating from a path, the sense is that you're moving away from your target, right? Or from the average in this case. So standard deviation is the standard way of measuring how far away from the mean, from the average data points are going to be located, right? And so that's what we're going to talk about. So it is very much connected to the range. The standard deviation and the range go hand in hand, okay? You can talk about both of them and arrive to the same conclusion, okay? So it measures how far data deviates from the mean. Standard deviation is very useful when comparing different data sets. Okay, so I know you probably don't hear this a lot, but especially now with Omicron and all these different variants that have come our way, and from province to province, when they look at hospitalizations and all those cases, right, there's an average number of cases, but then for every single one of these provinces, you could calculate the standard deviation. If the standard deviation is very high, that means that the actual case counts vary greatly. If the standard deviation is low, right, you're closer to the average, right? So your cases are actually pretty consistent, okay? So I will add to that a low standard deviation will result in data is close to the mean, and we can add these keywords: clustered, around, mean, or average, right? It's the same thing. Average and mean are the same. We're referring to the same thing. Data is consistent. You have a low range, okay? High minus low, right? So high minus low, remember that's your range. But the range, the difference between the lowest and the highest is going to be small. So remember, right, if your range is small, that means that the data is compact, it's clustered around the mean, right? If the high and the low is, if that difference is big, everything is spread out, right? I will add this to steep curve, right? If the standard deviation is low, the curve will be steeper, right? So for hospitals, a low standard deviation is a problem, right? Because that means that you will get a lot of people at once, right? So a high standard deviation, data is spread out. Oops. Spread out. Data is scattered. Further from the mean. Less consistent. You have a higher range. Flatter curve. Okay? So watch this. Let's make a line here. This is the low, this is the high. Because you only have so many cases, right, that you can consider. So the low and the high, this will be like a flat curve like this. Okay? Versus the steep curve, if you have your line here, the low and the high, we're going to exaggerate it a bit, right? They're closer together, so right, you have a steeper curve like that. And of course, if you have like many different countries, you're comparing different provinces, right? You can have them all on the same graph, and some will be steep and then some will be lower like that, right? And it all has to do with, you know, restrictions that were in place and various components, like how many people live in that area. Is it a dense area or not, right? Obviously, we can go on and on with that, but you would have different curves, some steeper than others, right? So I'm not going to show you how to calculate standard deviation by hand today. I will do that tomorrow. But here we go. Finding and we're going to focus a lot on the mean and the standard deviation moving forward. Finding the mean and standard deviation using the TI-84. When presented with tables or charts, and I'm talking actually frequency tables, okay? These are actually frequency tables. We enter, right? Data, we enter data from the first column into L1 and second column into L2. Okay, so you'll have two columns, so you have to enter them both into L1 and L2, right? And then press stat calc one variable stat L1 comma L2. Okay, it is very important that you enter the L2 as well, right? Otherwise, one variable stat will think that it's just a bunch of numbers you're entering and not really see that the L2 represents how often that occurs, Okay, so here's a table for you. And I will just summarize it, right? So let's say we have salaries of employees, right? And how many employees fall in that category. Okay, so let's just have the headings for now. And so let's say we have 3,500, 4,000, 4,500, actually 4,200, 4,300. So those are the salaries, and then so you have 5 employees that make this much. You have 8 employees that make 4,000, 5 employees that make 4,200, and 2 employees that make 4,300 a month. Okay, that is your table. Like that. So if you have a table like that and I ask you find the mean and standard deviation, you can actually find mean, median, mode, all of them if you wanted to. But here it is. We enter this into L1, right? And this is entered into L2. This is the frequency. And this is the data that we're talking about, the dollar amount, right? So we go stat, calc, one variable stat, L1, comma, L2. Don't put a comma between, like the first one, just L1 as you always have. And let's go ahead and find out the mean, median, and the standard deviation. We won't do the mode because that it doesn't work. We could do the range. Absolutely. So grab your calculators. I know that some of you are copying the chart perhaps, so there. I'm going to clear whatever I have in there, and I'm going to enter that 3,500, 4,000, 4,200, 4,300. Okay, so you enter those. You go 5, 8, 5, 2. Just to clarify, how many employees are we talking about? Like how many occurrences do we have, right? 8 and 2 is 10. 5 and 5 is another 10, so 20. So N should be 20. Okay? 20 employees. Let's watch out for that. I actually will write this down. N is equal to, we'll write that down as well. We'll gather as much information as we can. So you've entered this into L1, that into L2. Let's go ahead and go stat, calc, one variable stat, L1, comma, L2. Hit enter, and there's your average. It's dollars, right? 39,500 or 39.55, sorry. I will write down my standard deviation. It's 281.91. My median is 4,000. And my range would be 4,300 minus 3,750. So that's 550, right? But the most important ones I wanted you to have are these two. I'm going to focus a lot of my attention on that. And oh, sorry guys. Not what I wanted. That was supposed to happen there. But now, this is what I want you to do here. What was N telling us on the calculator? 20, right? So n is indeed 20, which is what we want. If you forget to do that, so let's go back. I'm gonna go quit this screen. I'm gonna go up to one variable stat and forget to enter L2. I'm purposely forgetting that and hit enter. First of all, you get totally different answers. And what else do you notice about n? N is just 4. It is just assuming that you're just keeping track of 4 salaries of 4 employees, right? There's one here, one here, one here, one here. So it's just 4, which is wrong, right? So that's where the L2 comes in. It goes for frequency, okay? So you need to make sure you don't forget. Let's do another one. This one is slightly different, but it's still done the same way. Frequency table with intervals. You should not dread this one. This one is actually fairly straightforward to do. Okay, so let's do this. I'm just going to have a column with, let's give ourselves some room on purpose here. So I'm going to go here, length in centimeters, and flower. Okay, so this should be, so we have 14 to 15, 15 to 16. Notice that it always doubles up when you do one of these. 17 to 18, 18 to 19. I think we'll stop there. So sorry, I went a little bit over. Right, and so we have that on that side, and then number of flowers that fall within each category would be as follows like that. So let's say you're given something like this. And by the way, the numbers can be big, right? So you could have, you know, number of kilometers traveled per person, right, over a year, right? We're talking tens of thousands, right? So don't fixate on the numbers right now, fixate on the steps, like what is being done to get that, okay? If you wanted to find the mean and standard deviation of one of these, you need to figure out the midpoints. That's why I'm going to use a different color. Because you cannot enter this, right? Can't enter into L1 like as it is, right? Find midpoints. Okay, so you almost like don't worry about that, you just find the midpoints. In this case, it's very easy, right? I will just do this in your notes because the steps is what I want. Midpoint would be 14 plus 15 in brackets divided by 2. It's always divided by 2. That's 29 divided by 2. That's 14.5 centimeters. And this goes on and on and on for every single interval that you see here. So in this case, it's 14.5. This case, it's 15.6. Oh, sorry, 15.5. And this would be done the same. You would have done the same if you wanted a frequency polygon. You find the midpoints. 16 to 17, that's 16 and a half, 17 and a half, 18 and a half, right? So it will be consistent. Once you figure out the first two, you might be fine to just do it in your head, right? But just make sure you don't get that wrong. So this goes into L1. And then the frequency goes into L2. Okay? So I left some room here, and you will have room on an AC or test to do that on the side, right? So I will actually look for that, and I will give you a mark for that for finding the midpoints. So we go stat, edit, clear whatever's in there, and then we go 14.5, 15.5, 16.5, 17.5, 18.5, and then we go 2, 5, 12, 5, 1. Just gonna make a note over here, and I'm expecting, right, 7 and 12, that's 9, plus 1, that's, sorry, 19, plus 1 is 20, so 25. I'm expecting to have, I'm considering 25 flowers in this as my data point. So it's like, remember when we made our frequency table, we take it from a bunch of numbers and we put them in the different slots, right? So that's kind of what's happening here. So we're going to find X, standard deviation, and let's just focus on range here. These three, those are the only ones, let's say in this case, that I'm asking you for. So stat, calc, enter, L1, comma, L2. I look at that end there, that's 25. So my average length, right, is 1642 centimeters. My standard deviation, it's not the S, okay, it's this one right here, 0.93. It's important because a lot of students pick that one. It ends up being very similar, not all the time, but sometimes in this case. And so a lot of students think, oh, standard deviation S, that's the one. No, it's not, right? And then the range, I will just go, right, 14.5 minus 18.5, which we could see there. Centimeter range. Okay, so that's how you do those. Maybe what I will do is I will add my keystrokes here. Stat, calc, one variable stat, L1, comma, L2. That's what gave me this. Okay. And now I want you to work on, so for homework, page 232, 1 to 5, plus, this is an important one. It's actually not that bad. You're just gonna have to enter and find the mean and standard deviation for a bunch of players. This is in the booklet. I would do that first, maybe. Let me just double check the 232 to make sure that you're actually able to do all of that. Okay. It's asking you to do, the first one is asking you to do it by hand. So don't worry about calculating it by hand, just focus on the technology, because 1B is saying now use technology to verify how you did that by hand. Okay, so it's very important for you to practice this. And page 9, I will post the key to that, and please read, because stuff like that will be on upcoming ACs, right? So it'll be there for you to know how you should answer those ones. Okay. Other than that,